Hello, good afternoon. So many people here, huh? I'm glad you joined us. You know, on Friday afternoon after lunch, I'm usually gone by this time. But I'm glad to see so many people that want to talk, even though it's mostly me going to be talking, at least at the beginning, about MCP, BigQuery, agents, and Cloud Run. You know, all these words that you've probably heard over these days many, many times. So I'm not going to give you a break today. And before I start, I want to give you a bit of a premise why even like talking about these things and why MCP and why BigQuery, like, haven't you heard enough about it? You know, this industry, it has an interesting tradition of saying that something is all you need. You know, it started with attention is all you need. That is largely true still. But then we continued with other all you needs. First we started, we have this, agents. Agents is all you need. MCP is all you need. At some point people were saying evals is all you need, and then skills is all you need. Guess what? You need all of them, not just one, and there's no silver bullet. A bit about me, I'm a developer relations engineer. Those of you who build apps, whether those are, line of business apps, internal, external, for consumers, you know about these topics more than I do. So I'm here just to kind of spark thinking and maybe open some possibilities and kind of ways for you to explore. I'm going to give you like a big spoiler what we're going to talk about. First, for those of you who I'm not sure whether MCP servers are something that is useful. We're going to talk about that. We're going to talk about autonomous agents. And while we were planning the conference, the popularity and the significance of autonomy in agents increased dramatically. And we're going to talk about that as well in conjunction with MCP servers. And also making connection to our third big point, which is Cloud Run, which is one of our runtime platforms where you can run agents. I'm sure you've heard a lot about Gemini Enterprise, Agent Platform, and all those big innovations. Guess what? Cloud Run can also run your agents. And we're going to talk about my favorite part of this topic, selfishly, is Gemma 4. And we will see how Gemma 4 can actually drive your agents and be the brain and the engine and do many tasks that otherwise major, what they call like frontier models were able to do just 12 months ago. Think about what we will be able to do in 12 months. All right, so first, why MCP? Right? That's kind of the first question that I often ask myself. Especially now, we have skills, we have CLI tools, we have a lot of things, and most of all, we have agents that can code, and they can just write code, call APIs. They can run CLIs. Why do we need MCPs? But first, let's kind of separate skills and tools. Like we talk a lot about skills. Google shipped a library of skills, and one way or another, there's multiple skills every day that people create. And they're separate, right? Those skills, they still refer to resources. They still refer to code that you can execute. So one way or another, even when you use skills, you still use tools, right? That's the first distinction. The second part is that those tools, they can be organized, they can be deployed, scaled, protected in multiple ways, right? One way is when you have your laptop or a separate machine, and that machine drives, CLI, drives other tools that effectively execute on your behalf. And it's a different situation when you want to run something at scale, when you want to protect it, when you want to monitor it, and et cetera, et cetera. And this is where MCP comes into play. Now, specifically, the MCP that we're going to see today and talk a bit about is MCP for BigQuery. That's a special kind of MCP, which is different from what MCP started, like how MCP started initially. This is effectively a managed service that is exposed as MCP, and MCP itself, the MCP server, is a managed service, so Google takes care of it. It's not one of its kind, and Google is not the only company that exposes managed MCP servers, but it has two big benefits. First benefit is that it's made specifically for MCP, so it's not something that it's made specifically for BigQuery. It's not something that was just created as a form of giving and exposing BigQuery APIs, right? So a lot of MCP servers, they're often built like that. These services, they're built with BigQuery in mind and how people use BigQuery and what's important with BigQuery. And essentially, this is how all first-party Google MCP servers are built. And the second big difference is that it's all integrated within the Google Cloud Platform. So the security, the observability, the way you manage the APIs, governance, the way you let people use it, it's all part of this, this platform that was created for running first-party MCP servers in Google Cloud. Now, kind of going deeper into MCP, let's talk about this other part of the conversation, which is autonomous agents and MCP servers, right? Let's remember what Vlad said, just like as a separate statement. First, if you have code execution, why do you need MCP, right? If you have CLI commands, why do you need MCP? When you have an MCP server that is properly built and properly managed, you gain multiple, I would say, two groups of benefits in general, and that also applies to autonomous agents. First, you have a unified way to integrate and observe. That applies both the MCP as a standard, right? The unification comes from the standard. And if you use this standard across the board, you are able to integrate this MCP server into your workflow, into your application, to your bigger actual goal that you're trying to solve in a standardized way. And I'm sure the majority of this audience, you already tried MCP server, already integrated it in many ways. And it all starts from you running an agent locally, and it's probably a CLI or something, and then you connect MCP server, and it's usually an SDIO server, so it kind of runs on your machine, and it does something for your agents. And we all remember that at the beginning, and still it's a very much actual problem, people complain about a lack of security and the manageability in MCP servers. This is why having MCP server, it's only half of the solution, not even a half, I think. The second half of it is running it properly and using it properly, right? And like I said, when you deploy MCP servers in a centralized way and in a standardized way, which includes also how you authenticate and how you essentially give permissions for MCP servers to function, whether it's on behalf of the agent identity or on behalf of the user identity, depending on how the MCP server is configured, you get that unified way to integrate, observe, protect, and ultimately govern your MCP servers. The second group of benefits, and this is ultimately, I think, the biggest why when we talk about using tools and MCP server tools as, as a particular case, versus just code generation. Code generation is great. I'm a huge fan. I'm playing with it every day, right? It's part of my workflow. But at the end of the day, if you have a deterministic part of your workflow, if you have a way to kind of escape that non-deterministic world of generative models, do it. Like, why would you give up on this? And with that, we effectively see MCP first as a tool. It's just another tool that is deterministic, and we know how to call it. And it's relatively easy for LLM to figure out how to use the tool. So why don't do this? And MCP then just becomes a standard that we all can use as developers and as users, essentially. Knowing that, if there is an MCP server, if it implements certain ways to, authenticate, if it integrates with our security platform, which is right in Google Cloud, this IAM platform that manages security for us, if we all kind of adopt those standards, it just becomes easier to use them. Now, I wanted to talk about the thing that feels different in terms of the context of BigQuery and MCP, but it actually very much applicable to how we run MCP servers, how we use them, how we run our agents, and what actually drives our agent. I'm sure you heard a lot about Gemini Enterprise Agent Platform and how it can run agents. Guess what? Cloud Run also can run your agents. And when we talk about the autonomous agents, and agents specifically built with something that you've heard a lot about over the past week, which is Agent Development Kit. We announced it a year ago, and it made a big way to what it is today. And in case if you don't know, ADK now supports multiple ways to invoking the agent, and one of them is actually sort of special endpoints of ADK API server that can be called from services like PubSub or EventArc, which means that now you can truly enable autonomous agents with ADK, because you have these special ways to kind of invoke the agent and continue your session. Now, with Cloud Run, you can run your ADK agents and expose it in that way, and with additional orchestration layers, you can really drive your agents in a way that is, that was essentially developed when the industry was working on microservices. Right? You can apply all those practices to effectively long-running pieces of compute. So enough of that Cloud Run. Well, I wanted to give you a quick kind of overview of something that you probably know. Cloud Run has multiple types of ways to run your code, multiple ways of running your code, and it's organized by the type of the resource, the kind of internal way of saying how we run that container. First, and I'm going to start with services. That's the familiar to most of the people. It's like a web app, right? So you run your HTTP service. It may be a web app that people use, or it may be just a REST API. The biggest thing is that you have a request-based invocation through HTTPS. Jobs, this is your batch service, right? You want to run something that just works and then finishes. Maybe your agent turn, like I say, if you think of it in chat terms like agent turn, maybe that job. Or it may be fine-tuning a model. Or it may be, who knows, maybe processing some video. Like those, something that you work on something and then you finish it, and that's a job. Worker pools, these are interesting entities because worker pools, it's essentially that long, I would say even forever running piece of compute that kind of waits for a job to come. And in that way, it's similar to services because it waits for a request. It doesn't expose HTTP endpoint. It may be looking at your pub/sub topic. It may be waiting for a file to appear in some storage. Nevertheless, worker pool is something that constantly works, right? And just waits for thing to happen, and then it reacts, saves the result somewhere. That's worker pool. Now, this week we announced instances, which is somewhat kind of similar to jobs, but it's not because instances can run for a long time, and they can be very quickly spun up. So they are, in a way, the perfect way to run your autonomous agents. And you also probably heard about Sandbox. And there's actually multiple sandboxes. There are open source sandbox on Cloud Run. There's now official sandbox that we also announced. And that will be a way to run your code securely and in an isolated way so it doesn't actually damage your environment. Now, think about it. Like we take MCP servers that we talked about. We take Cloud Run. We take BigQuery MCP server. It's like, what else can we use, to kind of add to this mix and just play with it and see what MCPs and LLMs and different agentic harnesses can do. Like I mentioned, because I spoiled everything at the beginning, we're going to use Gemma 4. And this Gemma 4 model is actually deployed with a VLLM framework in Cloud Run with the RTX 6000 Pro GPUs. So this is my personal Gemma 4 instance. Only I use it. Nobody else knows the URL and has credentials. And in that way, like I can use as many tokens as I want. This is my personal model. And it runs in Cloud Run. Many of you might have already tried it on your personal machine. That's also a way. And with that, I'm going to switch to my favorite part, which is the demo. All right. So what you see is just the custom ADK client that I vibe coded entirely. I don't know what works, what doesn't, but the things that I care for, they work. The exercise that I've done, this exercise that I've done was primarily sparked, like how hard can it be to handle MCP authentication in a custom client? It's fine, like you use Gemini Enterprise. Okay, they handle the authentication for you. You use ADK Web if you're a developer. It can handle that for you. And I was like, well, what would it take? And honestly, I mean, LLM and Gemini did a great job working on it. So this agent is a simple data agent driven by Gemma 4. It has one tool, which is BigQuery MCP tool. It is also given information about New York City bike data set. It's an open data set. It has just two tables. One table contains city bike stations. Another table contains trips over multiple years. So the purpose of this exercise is not to show you how to build sophisticated data agents. We had other talks for that, and it's a long journey. It may look simple at the beginning, but with your specific data sets, it takes a lot, not only technically, but also organizationally. But we can see what Gem4 and Cloud Run with BigQuery MCP can do. And the first question that I want to ask it is, what data do you have? I already told you what data it has, but why don't we see it one more time? So it's a BigQuery public data data set. It has New York City bike tables in this data set. And right now, the agent, like it's told, don't use even, if you know about this data set, don't use that knowledge, figure out everything from scratch. And now it tries to go to BigQuery, but it doesn't have access. You may say, oh, it's a public data set, but we still have to run those jobs somewhere. So the agent doesn't have access to BigQuery to execute jobs. The data is public. But even if the data wasn't public, that'd be still the same flow. So now I receive this interruption from ADK as an event that effectively tells the front end that it needs to sign in. And I go through a standard sign-in process. I use my personal account and see how many questions I was asked. And now the agent continues getting different tables, and then it gets the table information and ultimately answers the question. Very simple question, very simple answer. In my opinion, Gem4 31B does a great job here. Now, let's try something more sophisticated. I obviously prepared this question in advance, and I hope after it worked probably 20 times, it's going to work for 21st time. The question is more how can I increase the revenue? So it's not just, oh, what data I have, what is the longest trip, what is the second longest trip in 2013. Those questions are simple. I like this more specific question, what can I do with my bike stations to increase revenue and suggest up to 10 locations? I cannot spend too much money if it requires investment. And let's see what the model will do. First, it reasons, and because it's an open model, it shows thinking. It reasons about the operations that it needs to start from. And obviously, first, just as before, we need to start with giving access to the agent. Giving access to BigQuery. Now it goes over the results, what tables it has, and figures out what to do next. What is ultimately the process of optimizing for bigger revenue. And Gem4 is well-trained models and has quite a lot of world knowledge about how people make money and what kind of data, for example, customers that it need to pay attention to figure out how to increase revenue using some actions across 10 different stations. So this takes some time. It's a real demo. I'm glad it works. Always demo codes, they're not so happy sometimes. And C, I think it executed SQL multiple times. First, actually, this is a very interesting moment. And this is what I would do as well. It tried to join two tables, which is stations and trips, by station ID, because every trip has start station ID and end station ID. But turns out those are different IDs. They even have different types. And the query obviously fails. Sometimes it runs a SQL, and SQL returns empty results. So it tries to figure out what's wrong. And it figures out that, oh, we cannot actually join by station ID. We have to use something else. It finds the station name. It's not perfect, because it's a string. It's slow, but it is something. And it uses names to join. And it already passed that, I think, passed that stage. It got essentially the list of top stations with different like total trips, customer trips, and the percentage of customers. And for those who are not familiar with this data set, they have customers and subscribers. Subscribers are people who are kind of paying the fee maybe once a year and use those city bikes. So getting those top numbers to understand what stations are used by subscribers, what stations are used by customers, what is the usage versus available stalls, et cetera, et cetera. So capacity, that's how they call it. Like essentially the capacity of the station, how many stalls and how many bikes essentially you can have at that station. Right, and I think that it reasons already on the final answer. And it gives us top stations with recommendations of what to do. I checked the Broadway and 36th, and it really says that it only has three stalls at that station, which is obviously something that we have to address, given that it has like 5,000 trips per one dock. So this is what Gemma can do when it's given access to the data using BigQuery MCP. Yay, thank you, and happy Friday, yeah?